Hey, Algebra 1, how are you? Good to see you. Yeah, it's the same outfit I was wearing today, but you're seeing me now on Friday. So I wanted to go through the stuff for today. Uh, First off, you guys are awesome. You guys know that. But I was going to go through these notes. Um, so the substitute will hand you out, similar to what I handed you today, a packet of notes that should be in front of you. It should be a front, back. And these will go along with everything that we've been working with. And so I hope you guys have a fantastic weekend and take care of one another. But I want to go in and let's have some fun. So we're gonna just teach you what this is about. So first, starting off on the board, this goes with the homework that was last night for you. So if you didn't quite get it done, well, here's your opportunity to make sure it's all done. And this would be pages 21 and 22, which was assigned to you last night, I believe. Let me open the correct binder, 21 and 22, and we'll go from there. I hope you have some fun plans for the weekend, and I hope you have some restful time. And I tried talking to all of you today about just decisions in school. So take care and think about what we had talked about. But today, let's go and we're going to be solving each of these. So our first problem up there talks about we want to solve for y. So how are we going to do this? Well, you know that by using our information, we'll just do the dotted line so you have it down. Remember, the dotted line represents the equal sign, right? I want to solve for this y. So things I want to do is I would probably move 2x over by subtracting it from both sides. Those cancel. So you wind up with 2y is equal to 20 minus 2x. We'll start talking about this, putting this in a regular order in a little bit. But for right now, we're just fine with doing this. It's still a positive 20, which you see right here. And then we have minus 2x. So let's get y by itself. Well, y and 2 are being held together by multiplication, so we'll use division to undo them, and then reduce where you can. So 20 over 2 is 10, minus 2 over 2 is 1, so minus x, or minus 1x. So there's our answer from your homework last night, page 20, or page 21 on that. Problem number 22 will look like this again. We're going to do the dotted line, and we're going to go through. So we're going to subtract 3x, because it's positive 3x right now. We subtract that from both sides, so I wind up with y equals negative 3x plus 9. Some of you might have it as y equals 9 minus 3x because it's a positive 9. Both of these answers are totally fine. You choose which one right now. We'll be trying to get it to look like that next week, but as far as right now, this problem like that is fine. Let's see, number 3. We have 1 minus 4. So this is one that we talked about that we've done. So really all I need to do to this problem is just add 4 to both sides, and then we wind up with y equals 1/2 x minus 6, still in parentheses, plus 4. Technically that's totally fine, but if it was a multiple choice question, I would have distributed the 1/2 across the parentheses. So half of 6 is negative 3, and then I still have the plus 4 to bring down. And those are like terms, so then I can go ahead and combine those together. So we get to a problem that looks like that. Let's see. Number 3, we want to solve for y. So again, I'm doing my dotted line, get y by itself. And let's subtract 3x. Oops, subtract 3x from both sides. And again, remember, you can't combine 3x and 4 because they're unlike terms. So you have 1/2 y is equal to 4 minus 3x. Of course, you could have it negative 3x plus 4 if you wanted to. And then how do I undo 1/2 y? Well, I multiply this by 2 over 1, which is the same thing as 2. I multiply all my terms, so those are going to cancel out. So I get 1y, which is y equals 8 minus 6x. And there's our answer right there. Okay? Number 5, we're solving for y, and again, using the pink dotted line, if it'll let me. So from here, I'm going to subtract 2x from both sides. That's positive 8, so it's 8 minus 2x. Of course, you could have negative 2x plus 8. And then I need to get y by itself, so I'm going to divide everything by 4 and reduce where you can. 8 over 4 is 2, and 2 over 4 reduces to 1 over 2, so 1/2 x. So you could have your answer like that. Some people might actually have an answer that looks like this. X over 2 is the same thing as 1/2 x. Which answer is correct? They're both correct. They're both the same answer. Okay. I'm going to dim the light so it looks a little easier on your eyes. Problem number 6. Again, solving for y. So here I have a positive 3x. Well, I have to subtract it from both sides. So I still have a 9y on the left side, and then I have 18 minus 3x, or I could have negative 3x plus 18, is your choice. Divide by 9, divide by 9, and divide by 9, because 9 and y are being held together by multiplication. So I wind up with 18 over 9 is 2, and then 3 over 9 reduces to 1/3. Keep the x. So this answer is totally fine. Some people might prefer to have it like this. And both answers are correct, okay? Hope you're all having a nice time, keeping busy. Not giving the sub a hard time? No? Okay, good. All right. Let's see, number 7. This is one of those where we can go ahead and I can just add 3 to both sides. And I have y equals 1/3 x minus 27 plus 3. That answer is fine. If it was multiple choice, I would distribute 1/3 here and here. So y equals 1/3 x. And then 1/3 times 27. Well, 3 goes into 27 9 times, so that's minus 9 plus 3. And then combine your two like terms, so y equals 1/3 x minus 6. So this answer is totally fine. This answer right here is actually fine as well. So it's your choice how you want to have it. I just don't have to worry about distributing. Okay. Number 8, we have y on both sides, and so we need to start thinking about, okay, which side do I want to have y on? Well, I'd probably get y over on this side, okay? So it's a positive 2, so I'm going to subtract 2 from both sides, or subtract 2y from both sides. Those are going to cancel. And we still have left over on this side 2x minus 2y plus 5, and that's going to be equal to 3x plus 11. So again, we want y all by itself, so I need to start moving things over. So I'll subtract 2x, so the x's go with the x's, and subtract 5. I'll do 2 steps in one. Those cancel out, so I get negative 2y, and the 5's canceled out as well because they subtracted. And then I have 3x minus 2x is 1x. That's the same as x plus 6. And then our last step is we still want y, well, negative 2 and y are being held together by multiplication. So if you divide both sides by negative 2, you can have y equals negative 1/2 x. Positive over negative is going to be negative. 6 over 2 is 3. So you can keep your answer like this. Some people might choose to have their answer be like this. Watch your negative. Keep your negative there. So negative x over 2 minus 3. Both answers, again, are completely appropriate. You choose which one works best for you, okay? Let's see. Problem number 9. Okay, the red line will be our dotted line. You see the same idea, I imagine. Again, I have a y on both sides, so I have to decide what side do I want the y on. Usually the left side is the side we want to keep it on. So you're going to subtract 4y from both sides. So this is going to give me on this side 4x. 6y minus 4y is plus 2y minus 11. And that's going to be equal to 2x. The y's cancel each other out, minus 9. Now I want to move everything on the left side over except for the y's. Okay? So I could subtract 4x, and I could subtract 4x. I can also add 11 and add 11. So I'm marking them in a column with their like terms. And these x's cancel out now. I'm left with 2y. The 11's cancel out. equals negative 2x plus 2. I still want y by itself, so 2 and y are being held together by multiplication. So divide everything by 2, and you find your answer is y is equal to, because those cancel, negative 2 over 2 is negative 1, so negative x. Okay, see that? And then plus 1, because 2 over 2 is 1. There's your answer. Number 10, I want to get my y, and again the red line will represent the equal sign. So I'm going to subtract 6x from both sides. So I get negative 2y is equal to negative 6x plus 12. Of course, I could have had it as 12 minus 6x. Same idea. And then 2 and y are being held together by multiplication, so I'm going to divide each side by negative 2. So I find that y is equal to negative over negative is positive, 6 over 2 is 3, and then an x, and then 12 over negative 2 is going to be negative, and it's going to be negative 6, where it reduces down. Okay, feeling okay, everybody? Not going too fast? You know, you can always hit pause if I went too fast for you, okay? And you might, if a neighbor's stuck on something, you know, be sure you can clear it up with them, but, you know, hit pause on both of your computers or your phones, and go through there. Okay, these are the notes from the next section. So this goes along on your notes that you're looking at in front of you, and it's the same type of concept. Okay, so here we go. I'm going to add 9x to both sides. So now our x's cancel each other out. So 3y is equal to 9x plus 24. Remember the sign on the 24 is positive. It's not a, you don't see a sign there, so it's positive. Yes, you could have 24 plus 9x if you wanted to. And then I'm going to divide everything by 3 because 3 and y are being multiplied, so those cancel. So y is equal to 3x. And then 24 divided by 3 is 8. So y equals 3x plus 8. Okay? Too bad. And my phone is going. I clearly did not put my phone up. Cool. All right. Next problem. I have a y on the right side, so let's leave it over there and we can flip it at the end. So I'm going to subtract 9 from both sides. So I get 3x minus 4 is equal to, and that's a negative 4. Remember, originally it was a negative up top right here. Okay? So as you start going through it, you're like, okay, well now negative 4 and y are being held together by multiplication. So if you divide each side by negative 4, I'm going to flip it now. So y is over here, those cancel, equals negative 3x over 4. So I put the 4 with both. So this step right here looks like this. And then, so that's expanding your fraction. And then you get negative 4 over negative 4. And negative over negative is positive, and that would be positive 1. Our next problem, again, we're going to solve for y. So I'm going to use my dotted line. So I'll subtract 3 from both sides. So the 3's cancel out nicely. So I have 1/5 y is equal to 2x. 4 subtract 3 is 1. And then I want to get rid of that 1/5. Well, it's 1/5 times y. So what I can do is multiply both sides by 5 over 1, which is the same thing as 5. So those are going to cancel. That's going to give me y over here. 5 times 2 is 10, and then the x comes along. 5 times 1 is 5. Okay? You all right? See, I do get messages from time to time. Yay. This problem, we're solving for x. Notice x is on the same side. So you have 4x, and then you have a 5xy. Those are not like terms right now because one is just 4x and one's 5xy. So what we want to do, this is a little bit deeper thought, so I'm not going to do my line yet, but what I'm going to do is, what do I have in common between these? So think about it. You have 4 times x, and I have 5x and y. What does it appear that I have the same? It appears I have an x. So I'm actually reverse distributing. The term is called factoring. So you're going to factor out an x, and you're going to use parentheses. So now you're going to group it. So you're undoing that. So if you undo x from 4x, you're left with just a 4. The plus sign comes along for the ride. If you factor a 4 or an x out of 5x and y, you're left with just a 5 and a y. Does that make sense? Okay, so just pause there and take a look at it. Does that make sense what I just did? If I redistributed it, I'd get x times 4 is 4x, x times 5y is 5xy. And remember, multiplication doesn't matter. Order's not important when you multiply numbers in a row or letters in a row. Okay? So now we're actually ready to start moving things around. And I only have one thing now to move. It's what's grouped. I'm going to move 4 plus 5y by dividing it. I'm going to move it over here as well. So this whole group right here cancels as well as this. That leaves me x over here, and then I get g over, and notice how I'm keeping it in parentheses. The parentheses aren't really necessary, but it's nice so you're showing the person who's grading that it's done. And then sometimes we would want to flip it over to have what we're solving for on the left side, not the right side. So just flip your entire problem over. And again, I can put it in parentheses. It's not really necessary, but the nice thing is you realize that that whole thing is a denominator on the bottom part of the fraction. This one is similar to what we just did. We have a 6x and we have a px. Well, 6 and p are obviously not like terms. What I should probably do here is I'm going to make one move first, and then we're going to take a look at it. I'm going to subtract 2 from both sides real quick. So I get z minus 2. That's a z right here, and that's a 2 right here. And then that's still going to be equal to 6x plus px. So what do I have in common between these two? Do I have an x in common? If so, you're going to undistribute it, so you're factoring it, outside. So you have a 6 outside, and then you're left with a 6 plus p on that side, okay? So x times this value. So now your last move is just to divide both sides by that quantity. So I'm going to divide this by 6p, and I'm also going to divide this 6 plus p. Now again, you don't necessarily have to have that in the denominator in parentheses. It's nice, the whole thing, z minus 2, that whole thing is over 6 plus p. And what's going to happen there is this 6p and this 6p cancel each other out. And I'm going to bring this up so we have some more room. So I wind up with z minus 2 over, and in parentheses, and again, this shows that this whole fraction bar is right there, 6 plus p, and that's going to be equal to x. And then you want the x on the left side, so just flip the whole thing over. Looks like that. Okay, so here's our answer. Okay, this one, we're solving for x. Notice I have ax minus bx. Well, ax and bx are not like terms, so what do I have in common between those two? And it's an x, and I'm going to go a minus b. If I redistribute it, a times x is ax, and a times b is bx, and the minus sign comes down, equals k. And I want to get x by itself. I have k by itself right now, right? So now I'm going to divide each side by a minus b. And I'll keep it in parentheses, so it shows the greater. You understand that whole thing is the denominator. And from there, this and this cancel. So now I have just x by itself, and I have k over a minus b. And again, it's nice to keep it grouped in parentheses so the grader realizes you have that. And this whole thing is your answer right here. Let's see, this problem, I'm subtracting 3x from both sides. I guess I can do my dotted line for you. So this is going to cancel that. So I have 2y left on the left side, and on the right side I have 8 minus 3x, or I could have minus 3x plus 8. It's positive 8. It's your choice how you want to leave it for right now. 2 and y are being held together by multiplication. So divide everything by 2. Those cancel. And you're going to get y equals 4 minus 3 over 2x. And there's my answer. And again, some people might choose to have their answer like this. We'll get to this in a little bit. Negative 3 over 2x. 3 over 2, that's a 2, I'm sorry. And it's a positive 4. So which answer is correct? Both of them are correct at this point. Okay? This one, I want to solve for y. So this is one of those where you only have one move, technically. You could do that. The 3's cancel out. So you get y equals 2 over 5 times x minus 10 minus 3. Okay? That answer's fine for right now. If it was Scantron, I would go, well, 2/5 times that and 2/5 times that. So we're going to go y is equal to 2/5 times x is 2 over 5x. 2 times negative 10 is negative 20, so I get negative 20 over 5 minus 3. 20 over 5, I'm going to bring this up top, is y equals 2 over 5x. Negative 20 over 5 is negative 4, and then I'm going to subtract 3 from that as well. So those are now like terms. So we can clean it up and say, well, y equals 2/5 minus 7. So that's the answer we're going to eventually start getting to. But right now, you can leave your answer like that, okay? Feeling all right? All right, this next problem on slide 21, I want h by itself. So let's get rid of my 2 over 1, multiply both sides by 2 over 1, or just 2 first. And what's going to happen here is that cancels out. So that leaves me 2a on the left side. Then I have h and then b plus big B on that side. So right there is being multiplied together. So I divide both sides by b plus b, little b. So I'm going to divide by this. I'm going to divide by this. Those cancel, so I'm left with, I'm going to have my h over here. I'm just flipping it over right now. 2a over b plus big B. And little b and big B are two different variables. So you can't add them together to get 2b, okay? Everyone good? Ooh, this one, I want to solve for that big capital L. All right. So let's start moving some things over. So I'm going to move things over for right now. I'm going to subtract pi r squared from both sides. So this and this cancel. So I'm left with s minus pi r squared over here. And that's going to be equal to 2 pi r and then L. What am I solving for? L, right? So 2 pi r and L are all being multiplied together. So I'm going to divide both sides by 2 pi r and 2 pi r. And the nice thing is the 2 cancels that, the pi cancels that, the r cancels that. And then I'm left with L. I'm flipping it over. L equals this whole part right here. Okay? S minus pi r squared over 2 pi r. There's my answer. Okay, so take your time and put these together. Hit pause if you need to, and collect your thoughts. Okay? So, the past couple problems we did are actually from pages 23 and 24 in your workbook. They are the odd problems. So, I've just done all the odd problems for you on page 23 and 24. So, write them down. You have the notes already because you just took them, or you can rewatch the video. But all those problems I just did from that section, match them up and go with it. And then I want you to take the rest of the period to finish up page 23 and 24 and get the even problems done. So that's 2, 4, 6, 8, 10, 12, etc. Okay? I want to make sure you guys have a great weekend. Take care of one another. Do me a big favor. If you have just borrowed one of the Chrome books to do this, would you please make sure that it's put in its right slot in the Chromebook cart, and also make sure you have it plugged in so it's charging. Sound fair? All right. I'm so very proud of each and every one of you. I want you to know that you have a great weekend. Rest up nicely. Get that page 23 and 24 all done, and I will collect that on Tuesday morning. So, because remember, we don't have school on Monday, 3-day weekend. So that's pretty cool, huh? Enjoy your family, enjoy your friends, rest up, and I'll see you guys on Tuesday. And again, just please make sure you're being appropriate with the sub. I mean, being a sub is not the best job out there. It's tough, but please be kind to the sub. Don't have that sub list your name as somebody who caused trouble. And I hope you have a fantastic rest of your week, and I will see you on Tuesday morning. Bye-bye.